Hi, everyone, and welcome to a new year and a new module. This module we're going to be doing is on chemical reactions, and we're going to start off by looking at chemical equations, which we should already be familiar with. Chemical equations are basically chemical sentences. They can be in a form of a word equation or chemical equations. The states of matter also need to be included. So we have solid, liquid, gas, and if you see AQ, that means an aqueous solution, which just means it's been dissolved in water. So in transforming a chemical equation to a words equation, you must include the number of moles and the states of matter as well as the correct nomenclature. So this was kind of review from module 5, lesson 1, which was just you practicing basically more nomenclature just into a equation. So the numbers in front are the coefficients, and we refer to those as the number of moles of that substance. We will talk more about moles in its whole own module, so we don't have to really worry about what it is, but just know what it's called. So we got, for this first one, we have 4 moles of solid iron. And the plus sign means those things are, what are they doing? They're reacting. So reacts with 3 moles of, you can say gaseous oxygen if you're fancy, or you can just say 3 moles of oxygen gas. And then an arrow we know is producing. So to produce 2 moles of, and that's solid, and to our nomenclature, this is iron 3 oxide. Okay, so I've just taken that chemical equation and turned it into a word equation. You can go backwards and forwards. You should be able to do both of this. For this next one, so we have 2 moles of liquid. H2O2 has a polyatomic ion. We should know this one is hydrogen peroxide. Now, there's only one reactant here, so it's not really producing anything, but it's breaking down to form the technical term, the chemistry term that we're going to use is decompose. So 2 moles of liquid hydrogen peroxide decomposes to form 2 moles of water and 1 mole of oxygen gas. Okay, and we don't need to put 2 moles of liquid water. Because that's redundant. Okay, so a skeletal equation is a chemical equation that does not indicate the relative amounts of reactants and products. So that would be these 2 equations if there were no coefficients. So this is also referred to as an unbalanced equation. Okay. All right. Other parts of chemical equations that are important, if there is energy or heat that's either included as a reactant, as a product, it can go over the arrow, or you can see here for this reaction, which is a combustion reaction, we'll go over those later, it's giving off heat, okay? Catalysts are substances that speed up the rate of a reaction, but is not used in the reaction. Catalysts are placed over the arrow in the reaction. So here, this is an unbalanced equation, okay? So this is showing us hydrogen peroxide decomposing into water and oxygen gas. So there are plenty of catalysts. I think in the video, it uses potassium iodide. You could also use bleach. Bleach is also a catalyst for this reaction. So yeah. So it would go over the arrow. You could also have it as both a reactant and a product to show that nothing has happened. It was started as a reactant, it came out as a product, so it didn't do anything. And then the last thing for this one is balancing chemical equations. Now this is very simple. Like I said, those coefficients are the numbers in front used to show the relative amounts of the material. And according to the law of conservation of mass, there must be the same number of atoms on both sides of the equation, and that's why we have to balance our equations. So, steps to writing a correct balanced equation. Write the correct formulas for all the reactants and products. If you do not write the correct formulas, you're not going to be able to balance it, all right? Count the number of atoms of each element, and you can treat polyatomic ions as units as long as they occur on both sides of the equations, and I'll show you in these examples. Start by balancing elements that only show up once, and you cannot change the subscripts. That's super important. All we're doing is putting coefficients. And those coefficients have to be in the lowest whole number ratio. So if you have a 2, a 2, a 2, and a 4, that needs to be reduced down to 1, 1, 1, and 2. Okay. And typically all I do is start on the left side of my equation and balance as I go down the line. Nothing too crazy. So we'll start off by doing our formulas. So let's see, I always put a line in front of my formula because that's where I'm going to balance instead of just having to squeeze it in. Dihydrogen sulfide gas, that would be H2S as a gas, is bubbled through, that's a reaction of an aqueous silver nitrate, which is just AgNO3. And of course, if we still need to, we can take the charges and swap them so that we can get the correct formula. So it'd be AgNO3. To produce an aqueous solution of nitric acid, HNO3, aqueous, and solid silver sulfide. So Ag+1, sulfur -2, that's going to give me Ag2S as a solid. So now I want to go and I want to balance them. So you can see here I've got two hydrogens on the left side. I've got one hydrogen here. I'm going to put a 2 in front of that, and I'm just going to put a little tick mark above the hydrogen because that's balanced. Now we go to the S. I've got one S on the left, one S on the right. That's balanced. Check and check. Now the silvers. Well, I've got 1 on the left, but I've got 2 on the right, so I need to put a 2 in front of that silver nitrate, which now, so that silver's good. And now I see I have nitrate on both sides, so I can balance them together as the nitrate. I've got 2 on the left and 2 on the right, and that's balanced. And there's my balanced equation. 1 mole of dihydrogen sulfide gas is bubbled through 2 moles of aqueous silver nitrate to produce 2 moles of nitric acid and 1 mole of solid silver sulfide. That's it. Balancing equations is super simple, and it just takes practice. So the next one, solid manganese 4 oxide. So manganese plus 4 oxygen -2 gives me Mn2O4, and of course we can reduce that down to MnO2, solid, is placed in an aqueous solution of hydrochloric acid to produce solid manganese 2 chloride, MnCl2, oh, solid, excuse me. Water, and so if we say water, that's implied that it's a liquid, and chlorine gas. Now don't forget our diatomic molecules, that's still Cl2. Now we go and balance it. I've got 1 Mn manganese on the left, 1 manganese on the right. I've got 2 oxygens on the left. Now I need to make it 2 oxygens on the right, so I'm going to put a 2 in front of this water. So the oxygens are good. Hydrogen on the left, I've got 1. On the right, I have 4. So I need to put a 4 in front of this. So then those hydrogens are balanced. And then finally, chlorines. I've got 4 on the left. I've got 2 here and 2 here, which gives me 4 on the right, and it's balanced. It's really super simple as long as you can count. Well, no, let me take that back. As long as you can write the balanced equation properly, then it's going to be fine. Finally, on this example here, aqueous solutions of zinc hydroxide. Remember, if you've got more than one polyatomic ion, it needs to go in parentheses. And phosphoric acid, H3PO4. So if you can't tell by now, if you are struggling with your nomenclature, this unit is not going to be the one for you, okay? So you need to make sure that you're practicing your nomenclature to form water and solid zinc sulfate. Okay. Okay, now to balance it, I've got 1 zinc on the left, I have 3 on the right, so I need to pop a 3 there, so the zincs are good. Now, for the hydroxides, there's a trick. If you have hydroxide on one side and you have water on the other, if you balance it HOH, you can compare OHs and you can compare the H here. Okay, just makes it easier so you have less things to do and you can keep that polyatomic ion together. So in this case, I have 6 hydroxides on the left side. I need to put a 6 here to give me 6 hydroxides on the right. So I'm going to check that off. Hydrogens on the left, there's 3, and I have 6, because there's a 6 here, on the right. So I need to put a 2 in front of this phosphoric acid, and that also gives me 2 phosphates, which balance. And then that's your balanced equation, 3, 2, 6, 1. And remember, we don't need to put 1s, so if it's a blank, just leave it as a 1. Okay, so for your homework, for your practicing, you're going to take your answers, your written out formulas, unbalanced from module 5, lesson 1's assignment, and you're going to balance those unbalanced equations for your module 5, lesson 2 assignment. Okay, there's also another assignment that is like a practice quiz for you to balance. You need to just screenshot your results and send them to me in your assignment. But there is just one last thing I want to just briefly touch on because we're going to be talking more about this later, and that's solubility. Solubility is basically how well something can dissolve in something else. To determine solubility, you have to understand the polarity of molecules, which we know. We've already done polarity. And we know polar things will dissolve polar things and non-polar things will dissolve non-polar things. Also keep in mind polar dissolves ionic. Like water can dissolve salt. That's also super important. So if I have the following, hexane, water, which is C6H14, water, acetone, and ethanol. The OL, that makes it an alcohol. It's got an OH group. We know alcohols are polar. We know water is polar. Okay. And then acetone is also polar. Okay. So what things will mix together? Okay. Well, we know hexane, I'm sorry, is nonpolar. So if I tried to mix all these things together, I would get 2 separate layers. I would get a nonpolar layer, which would include the hexane, and then I would have a polar layer where these 3 things would mix together because they're all polar. All right, that's just a very basic definition of what solubility is. What will we be doing with this? Well, in the next lesson, we're going to end up predicting what the products of a chemical reaction are. So looking at what type of reaction is, we're going to be able to predict what those products are. And so with that, we're going to look at the solubility rules. And the solubility rules will help us determine what state of matter is this product. Okay, but we're going to talk more about that in the next lesson. So that's it for this note. If you have any questions, please make sure that you ask them in the chat or at the end of class. And then I will be back with the next notes.